All right, hello again, pre-calculus people. Hope you're doing well. So the next couple of sections that we're going to be doing, call it kind of like other trig topics. And everyone, in my experience, everyone seems to kind of enjoy these a little more. They're much more computational. There's no tricks to them. They're formulaic. So I think we'll do well in these next couple sections here. And what this is, so we're going to start talking about something called the law of sines and the law of cosines. And today's video just about the law of sines, but I'm going to kind of talk about when we're going to use the different laws, even though we're not talking about the law of cosines today. So basically, it's a way for us to solve for missing pieces of triangles that are not right triangles. So up until now, we've only been able to solve right triangles, but like SOHCAHTOA and stuff like that. The law of sines and the law of cosines enables us to find our missing pieces, either sides or angles of any triangle of any shape, not just right triangles. So what we're going to be doing today is law of sines, and there's another case we use law of sines for, but I'm going to do a whole separate video on that. But for today, we're going to be talking about this first bullet point. So if we're given any two angles and any one side of a triangle, we're going to use this law of sines. And the next video that I'll do in a day or so is going to be on the law of cosines, and that we'll use if we're given either all three sides, want to find what the measure of the three angles are, or if we have two sides in the included angle, which is what we call the SAS case. But we're just going to do the law of sines today on the normal case where we have two angles in any one given side. So what is the law of sines? Law of sines is this. Basically what it says, I'm not going to go through the derivation of it, but basically what it says is if you take the ratio of the sine of an angle divided by its side, by that corresponding side, that ratio is the same for all three pairs, all three angle side pairs, which is kind of cool. So the main thing when we set this up is, if you just draw a random triangle, and I don't care how the triangle looks, but if I put the A, B, and the C in those places, for example, the main thing to remember is that the angle side pair are always opposite from each other. So if this is angle A, this has to be side A. If this is angle B, this has to be side B. And if that's angle C, this has to be side C. That is always the convention. That I don't care who your teacher is or where you're seeing this, that angle side pair, they're always opposite from each other. Okay? So look, in this first case, if we're given two angles, then obviously we've known how to find the third angle of a triangle since our middle school days, if not elementary school days. So we can just take 180 minus the sum of the two given angles. And then once we have the three angles, then we can start looking at the ratio setup, how to set up the different things. And then we're basically going to do cross multiplying and dividing, again, from middle school days, and let the calculator do all the work from there. The one thing, and I'll mention this again when we get to the first example, is do make sure whether you're using Desmos or a calculator or heck, even your phone. I think most phones these days can do these kind of questions. Just make sure that in the settings that you change that to degrees and that you're not in radians. That'll make a big difference. Okay, so let's go and jump into an example here. So this is what a question is going to look like. It's going to say what you're given, and you need to find everything else. Okay, so and what I always do, I just draw a random triangle. I don't care what it looks like or how accurate the angles are or whatever. I just draw just to kind of get a visual of what's happening. So again, I'm going to put the A, B, and C there. And if my angle A is 38, and my angle C is 22, and then my side A is 10, again, always across, it'll be right there. Okay, so let's go and find angle B first. So it'll be 180 minus 38 minus 22. 38, 22 is 60, so 180 minus 60 is 120. That'll be right there. And this is a good illustration of why my triangles are usually not very accurate, because clearly this is not a 120-degree angle. But again, I don't care what the triangle looks like. All I care about is the value for the different things I'm trying to find. Okay, so what are we looking for now? If we're given side A, now we have all three angles. So we're looking for what side B is, and we're looking for what side C is. It doesn't matter what you do first, but let's remind ourselves from the front page what the law of sine says. So it says the ratio of the sine over the side is equal for all three pairs. Okay, so the question you ask yourself as soon as you get your angle done is, what pair do I know everything about? In other words, which pair do I have both the angle and the side basically given to me? And in this case, I know everything about the A, right? So I'm going to start with that. So I'm going to write sine of 38 over 10. And if I want to find the B side first, I'm going to set up that ratio. So sine of 120 over B. Now, you only do two at a time. I know all three of them are equal, and they're like, do you do all three? No. You just do one thing at a time so you can find side B, and then we'll do it again and set these two equal to each other to find side C. Okay? And this is your old friend, cross multiply and divide. So I'm going to write that as B times sine 38 equals 10 sine 120. Now you'll notice too, I'm not figuring out what these individual values are because I don't care. I'm going to let the calculator do all the work at the end at one time. Okay, but remember, I do want to get B by itself, so I need to divide both sides by sine 38. So B is going to be equal to 10 sine 120 over sine 38. And then you put that in your calculator. Again, just as a reminder, once again, whether you're using Desmos or whatever you're using, make sure you're going into the settings. In Desmos, on the right-hand side, there's a little wrench icon. Click on that wrench at the bottom. You're going to see where it says degrees. Make sure that's highlighted. I'm not going to show you that on screen just to keep the video time a little bit less. But if you type that in, again, just type it in exactly the way it looks, as long as you're in degrees. And when you type that in, you should get a value of 14.066. I generally want 2 decimal places. So when I write the final answer, I would take either 14.06 or 14.07, either one you want to write. You can either truncate or round, as it's called. And then for side C, we do the same thing. So again, now we stick with what we know, right? So we still stick with the sine 38 over 10. But now we do the C ratio. So now it's sine 22 over little c. You do the cross multiply and divide thing. And we have C sine 38 equals 10 sine 22. And then again, when you divide, I'm kind of running out of room here, but when you divide, you would have C is equal to 10 sine 22 over sine 38, and you pop that into your calculator, and you should get 6.085, which again, second decimal place, I would take either 6.08 or 6.09. That's your final answer on that one. And that's how you use the law of sines. Now, the one little check that you can do to make sure that your values kind of make sense. Remember, when you talk about triangles, even back again in your middle school days, whatever the biggest angle is, that corresponding side is going to be the longest side. So in this case here, I know since my angle B was 120, I know side B has to be the longest of the 3 sides. And if you look at 14 as opposed to 10 or 6, that checks out. And then the shortest side will be opposite the smallest angle. So is side C the smallest? It is. So that seems to check out pretty good. Is that a surefire way to know that you did it right? No, but at least it will kind of catch some bigger errors. Okay, so I got one more example. I'm going to let you guys pause the video and kind of work on this yourself, but I'm going to sketch it first. So again, I'm just going to sketch just a random triangle. Label for what I know. So I know angle A is 66, angle B is 40, and side C is 24, so that'll be down here. So I'm looking for angle A, and I'm looking for, looking for side A and side B. Okay, so let's find angle C first. So again, easy, just subtracting. And that's, let's see, that's 116. What's that going to be? 74? 106, I should say. 180 minus 106, 74. So stick that up there. Okay, so again, law of sines. Which pair do we have everything for? Right, in this case, I've got, now that I know that third angle, I know the whole C pair. So I'm going to start with that. So sine 74 over 24. And what would I set that equal to? If I'm looking for side A first, let's say, what would my other fraction be? Well, that would be sine of 66 over A. So again, I'm going to ask you pause the video real fast, do the cross multiplying and dividing and see what you get. And then here in about 5 seconds, I'll run through what the answer is. So if we cross multiply, we have this. So we have A sine 74 equals 24 sine 66, which would mean A would be 24 sine 66 divided by sine 74, which would be, stick that into your Desmos or whatever calculator you're using, 22.808. So again, 28.80 or 22.81. And then same thing for side B. Again, use the pair that you know, so that first fraction doesn't change at all. And then we can do this, the angle B in side B pair. Sine 40 over B. Cross multiply. And then divide. And if you do 24 sine 40 divided by sine 74, you get 16.048. So 16.04 or 16.05. Excuse me. So that is the main process of using the law of sines. If you're given two angles on one side, there is another situation where we use the law of sines when we have two sides and the not included angle. But that's what we call the ambiguous case. So I'm going to do a whole separate video on doing that case because there's some weird things that happen. Next video will be the law of cosines. And until next, if you have any questions, as always, feel free to come and talk to me, send me a message. And until next time, stay safe.